Assalamualaikum warahmatullahi wabarakatuh. Today, we will present about a network analysis presentation group 5. The objective for this assignment is we need to analyze the IC circuit. Next, we need to understand real power, reactive power, and complex power in an AC circuit. Third, we need to apply power factor correction system in an AC circuit. And lastly, we need to simulate the analysis. From the assignment, the task 1 given is we need to calculate the impedance of each load. Finding impedance in this circuit applies voltage is divided by complex power. Voltage supply for each branch is first calculated by using the voltage divider theorem, such as this formula. Then by applying the formula Z equal to V squared modulus over S conjugate, we will be able to search the value from impedance 1, impedance 2, and impedance 3, and also the total impedance of this circuit. Then loads are then converted to resistor and inductor or capacitor to be included in the circuit using the formula below. That is XL equal to 2 pi FL and XC is equal to 1 over 2 pi FC. That we can get the inductor and the capacitor for the circuit. Then we calculate the voltage supply. To calculate voltage supply, we need to imply voltage divider theory. Next, we calculate the current flow. The current flow in the load is determined by the conjugate of division complex power by voltage. By using this formula, we can calculate the current flow through load 1, load 2, and load 3. So then supply current is calculated by using Ohm's law, where supply voltage is divided by total impedance. That is IT equal to Vs over Z total.
Okay, next we find the real power and reactive power loss at the transmission line. The real power of the circuit is calculated by product of impedance and square of the current flowing in it. For the line 34, the power we got 944.2 plus 2360.5 I. For the line 23 here, we got the power 2713.27 plus 1 plus 8139.8 I. And for the line 1 2, the power we got 7392 plus 16632.03 I. Next is for the power in the system. It is determined by the system whether it is lagging or leading by observing the phase angle here, whether it is negative or positive value. So in our case, we got the phase angle positive 27.42. So the system will be lagging. If the negative phase angle here, it will be the leading system. Using this power triangle, for the angle here, we put our S for the hypotenuse and real power P for the adjacent, and Q is at the opposite of the angle. Okay, next is power factor correction. After we got the power in our system, the angle, we can calculate the power factor to improve the factor to 0.98 because we have to increase the efficiency of the system. So the formula is power factor equal to cos theta, or the cos angle, phase angle. For the new power factor obtained, we can obtain the capacitor correction required to improve the system. So the formula is QC is equal to Q old minus Q new. The capacitor will act as a capacitor bank by placing it in shunt. So we use this correction, and we can get the new phase angle for after the correction. So our new phase angle is 11.48, and it is in positive value. Okay, next we will discuss about the calculation simulation with the real life application. The real power and reactive power in the system effect on the efficiency of the system. The power loss in the system is what every engineer will avoid. Therefore, power factor correction is essential in a system. Power factor correction would decrease the power loss in transmission line, and the reactive power shows decrease after the power factor correction, while the real power shows a slight increase. The calculation and simulation prove that with the added capacitor in the circuit, it will increase the efficiency of the system. For the example of the real-life application, a steel clamping operations run at 100 kilowatt, and the apparent power meter records 125 kV. To find the power factor, divide the working power and apparent power to yield a power factor of 80%. This means that only 80% of the incoming current does useful work, and 20% is wasted through heating up the conductors. And in conclusions, improving the power factor can maximize current carrying capacity, improve voltage equipment, reduce power losses, and lower electric bills. The simplest way to improve power factor is to add the power factor correction capacitors to the electrical system. So we can conclude that the power factor correction is very crucial to the system, because a poor power factor will result in significant energy wastage, decrease the capacity of the electrical systems.